Today we will be discussing the development of the periodic table. The first person who contributed to the periodic table's development that I would like to speak on is Anton Lavoisier. Anton Lavassier organized the elements as gases, metals, nonmetals, and what he referred to as earths. We also had Dmitri Mendeleev. Dmitri organized the elements by increasing atomic mass in a table. With that organization, he was able to predict that there were missing elements, and he left room for them in his table for where they ought to go. His predictions were correct. Those elements did in fact exist, and we have found them since. The last person that I would like to mention is Henry Moseley. Henry Moseley is the father of the modern periodic table. He organized the elements by increasing in atomic number rather than atomic mass, and this has led to a better, more representative table about the actual chemical properties and predictability of the table. Our current periodic table is organized into a couple of different categories. First, we have our groups. Our groups are running vertically up and down. They are also known as columns or families. Elements within the same group will have similar chemical properties and bonding characteristics. They have similar properties and bonding characteristics specifically because the bonding characteristics and properties are determined by the number of valence electrons. And inside of the groups, everyone will have the same number of valence electrons. So that's our vertical organization. Our horizontal organization, our rows, are going to be running from left to right. And elements within the same row are going to have increasing atomic numbers. As a reminder, my atomic number is also my number of protons. I mentioned valence electrons earlier when I was speaking on the group organization, but as a reminder, valence electrons are going to be my outermost electrons. Shorthand for electron is E negative, shorthand for proton is P positive. Valence electrons are the only electrons that are utilized in bonding, and my group number is going to tell you how many. There is a caveat to group number telling you how many, and this caveat is specifically in reference to whether the group number is followed by an A or a B. So this column with group number 1A, this column has one valence electron. However, here where we have the column number followed by a B, this is going to not predict the number of valence electrons. My transition metal block, as well as my lanthanides and actinides, way down at the bottom, do not follow the group number telling you how many valence electrons. Only the group numbers followed by A will do this. Lastly, I wanted to talk about the specific characteristics of the three main types or subsections of elements that are in the periodic table. Firstly, we have metals. Metals in general are going to be good conductors. They're going to be malleable, ductile, lustrous, and opaque, and they will be mostly solid at room temperature. My nonmetals are going to be poor conductors, brittle, dull, transparent, and they can be solid, liquid, or a gas at room temperature. Finally, we have my metalloids. My metalloids are going to be semiconductors. They will be brittle but lustrous and solid at room temperature. My metalloids are the middle ground between metals and nonmetals. We will discuss more in depth on where metals, nonmetals, and metalloids are on the periodic table in the next video.